Hello everyone, welcome to the third part of this series of videos on Scientometrics. In this video I'm going to present how to use CiteSpace, which is a software package which you can use for visualizing your co-citation analysis and also estimating the homogeneity and precision of your analysis. So this is a very useful website which you can visit. And I think you can get a lot of useful information about CiteSpace analysis. Okay, so what I'm going to cover in this presentation is to use CiteSpace itself. I have already downloaded CiteSpace. I'll provide you the link to the website where you can download CiteSpace. It's a free package, and so you won't have to make any payments for it. So CiteSpace, the version that I'm using for CiteSpace is version 5.6.R3, revision 3. So it's an executable file as long as you have downloaded it on your computer. You can actually analyze your data using it. So I'm going to double click on this, and it's going to take a little bit of time for you to see CiteSpace. First of all, this window appears. And what you expect to see is a bunch of, codes here that shows the CiteSpace is working. And after this, you'll see a lot of folders that will be generated on your desktop. If you have done CiteSpace analysis before, like I did, let me just minimize this to explain these folders. These folders will be generated. Each two folders are for one analysis that you have carried out in the past. So what I'm going to do is really just to delete them. In order to avoid the creation of these folders, what you could do is to park every analysis that you run in one particular folder designated for CiteSpace analysis on your computer. I haven't done that, so every time I open CiteSpace I see this mess. I'm afraid that's my own fault. So I'm going to minimize this and go to the main window of the software. It says CiteSpace Welcome. And if you like, you can donate. Actually, I suggest that you donate to this wonderful project. Here is CiteSpace Welcome. You probably didn't see that before. Now what happens is you don't see any buttons. At least on my computer you can't see it because it's hidden right at the bottom. So I'm going to click maximize, and I'll see this agree disagree button. So I have to choose agree in order to be able to see the interface of CiteSpace. For a very useful list of references, you can actually click on these because they have hyperlinks, and they can navigate you to the website where the paper has been published. So they are really useful. You can actually read them when you have time. So I'm going to click agree in order to be navigated to the CiteSpace window. So here is what I have. That's the window of CiteSpace. Okay. So CiteSpace basically has a lot of buttons on its interface. Therefore, it's important that we choose the right button and select the best parameters for our analysis. Now, the first thing that I would like to highlight is that you need to create a folder even before this analysis starts, and that's something that I've already done. This is CiteSpace, the CiteSpace folder. I've called it CiteSpace. You can call it anything else really, depending on your analysis. So I open it, and you see I have a data set and a project folder in it. And the data is the data that I downloaded. If you look at the first video of Scientometrics series, you can see how I downloaded this. This is from the Web of Science. I go back to project. I also have a project which is currently empty except for this configuration file that was generated because I was doing some analysis. And just ignore this. I think this was just created. Basically, I can delete it. Yes. It's nothing. So you only have need to have two files. One called data, where you park your data, and the other one is project, where basically the results of the analysis will be saved. So I'm going to minimize this and go back to CiteSpace. What you need to do is to create a new analysis, and I've already done that actually. So I already created a lead listen. So I'm going to remove this. That's how you remove projects. It's very easy. And I'm going to create a new one. Click on new, and you will be directed to this website, to this part of the software, to this window. I'm going to choose read listen, because the data that I've collected is about reading and listening comprehension. Actually, you can call it anything else. Now, it's very important to navigate through these two buttons properly, because if you designate the wrong folder to each of these two buttons or these two options, the analysis might not run or will not run. So the first thing that we need to do is to find our project, then our data. So the project will go to the project here in the CiteSpace folder. We have to go here. I'm gonna find the desktop, which is right here, and CiteSpace. So and this is where you see that naming those folders is really important, because where you park your data, where you would like the project to be saved, is consistent with the naming here. So I need to choose project for the project home. So I'm going to choose project and open. Then data directory, or basically I go back to the same folder. CiteSpace can find it automatically because you have already opened it once. And data, for data directory, I'm going to choose a directory that I've already created and click open, and that's it. So my data file, my database is basically Web of Science. If you have downloaded your data from other databases like Scopus, Lens, etc., you can actually choose them. Now, there are a lot of buttons here. I don't suggest that you change much of these default sections, default buttons. What I would like to explain just a little bit here is the look back years on the one hand, and link retaining factor, because they can help you change the properties of your analysis and the network that you create. Now, look back years is a parameter that shows the length of citation links from the source article published, say, in a year like year 1999, to target articles published in another year. So, in other words, it provides information that's useful for understanding the long-term impact of your target article. So if you like to keep citations to your target articles published a long time ago, you probably want to just choose -1 instead of 8. But the default is 8. What does that mean? It means ignore all citations to references that are more than 8 years old. So you have a bunch of references in the papers that you want to analyze. If these references have been cited in more than 8 years ago, relative to the time of analysis, then just ignore them. And that's probably limiting for some people. What I would like to do for this analysis is to change it to -1, so I won't have that limitation. I think this will probably make my network, which has a small number of papers in it, probably more reliable. I say probably because, as I will show you later, you probably need to do some comparison, to run some comparative analyses between to compare your networks that you will generate using different parameters to find out which one gives you gives more precision and more homogeneity. I'll explain that in a minute. So then we have got link retaining factors, and in the same way, this is 3. You can actually change it to -1, especially is especially useful when you have a very highly connected network. So I'm going to keep it as -1, and I'm not going to change anything else. So I will save this, and that's it. Now the data set that I have created, if you recall from the first video, is from 2016 or 2015, almost 2019. Just to be on the safe side, I'm going to choose 2015 to 2020, that's this year. Then we have got years per slice. So what CiteSpace is going to do is to slice your data into several slices. So from 2015 to 2020, you're going to have 2015 to 2016, that's slice 1, then 16 to 17, that's slice 2, that's 17 to 18, slice 3, 18 to 19, slice 4, and 19 to 20, slice 5. Now, if you want to keep only 1 year in each slice, you could actually change this to 2, or the maximum of, how many years are there? A maximum of 106. In other words, in one slice, you're going to have 1 year, or 2 years, or 3 years. Now I have around 5 years from 2015 to 2020. If I choose 5, then I'm going to end up having 1 slice. So the data will not be sliced for me. What does it mean? It means that really each slice will represent data from 1 year, and if you change it to 2, your slices will represent data from 2 years, and so on and so forth. Now for text processing, I'm going to click everything. I think I highly recommend that you do text processing using titles, abstracts, author, keywords, and keywords plus, because that helps us run the analysis. And I'm not going to choose term types. I'm not going to change term types. In CiteSpace, we have the option to do all sort of co-citation analysis. If you put your cursor on the first option which has been chosen, you see this little pop-up window tells us that this is going to be a document co-citation network, or document co-citation analysis, and that's the most powerful feature of CiteSpace. So I'm going to leave it as is. But if you would like to do author co-citation analysis, you could also do that. You can just click this button and do not unclick references, just keep it as is. But this is going to make your analysis a bit complicated. And if you want to include a journal co-citation analysis, as you see from this little pop-up window there, you can just click or unclick it. Just check it off or unclick it. There are other options for you. For example, bibliographic coupling. This is the analysis based on grants. This is based on claims, categories, keywords. This is co-occurring keywords analysis, or keyword co-citation analysis. And based on countries, a co-citation analysis of countries, like authors from what country cite authors from what other countries, and so on. And institutions as well. Actually, you can run this analysis to find what institute has been co-cited the most, or what actually that means authors from what institute have been co-cited the most, and also this one for co-authorship networks analysis. What I have usually done often done in previous research that I have conducted is reference with document co-citation analysis, author co-citation analysis, and cited journal analysis. I have also looked into countries and institutions. But for this analysis, I really like to stick with the most powerful feature here. I'm going to unclick this cited authors, and I'm going to leave a reference, which is document co-citation analysis. Now for selection criteria, as you see, you have quite a few options here. First of all is G-index. Let me go to the Wikipedia. Just show you. It's actually a very short page, and you'll enjoy reading it. So a G-index has been explained here. Well, a G-index is the largest number that equals the average number of citations of the most highly cited G publications. So the G-index is usually larger than the H-index, And there is a claim that it's more reliable than H-index, so actually, or more, if not reliable, actually more useful than an H-index. So you can keep G-index at 25. Now you might be asking me, is 25 the best? I recommend that you, for example, run a network with 25 G-index, then another one with 50, then another one with 10, depending on how large your data set is, to be able to generate the silhouette index. That's the homogeneity of cluster, an indication of the homogeneity of clustering, and also the modularity Q, which basically shows whether your that's actually the precision of clustering, whether your network can be broken down into clusters, and compare them to see what happens. I will show you a comparison in a minute. Then you can choose top-down and top-N papers. Research shows that G-index returns a more reliable and more precise kind of network than top N. For example, using 50, keying in 50, which is a default here, you can select the top 50 levels of most cited or occurred items from each slice. So each slice will only include 50 top most cited papers. So you can actually increase this if you feel like you need to have a larger network. And if you want to include you know, a percentage of the top most cited papers in your network, you can actually choose a key in here, like select the top 10% of the most cited or occurred items from each slice. Maximum number of selected items per slice is 100. You can change all of these parameters. So then you can actually choose the rest of them, like you choose thresholds. Things get complicated here, really. And you can choose citations, you can usage 180, usage 2013, and so on and so forth. So again, according to the developer of the software, Professor Chen, this G-index analysis seems to be more reliable and more efficient in terms of the analysis. Now, what I would like to do is to run the analysis here. Just let me drag this to fit the window for you. So I'm going to click go. I don't change anything else, pathfinders and so on and so forth. I might really talk about these because they are more advanced topics, and for visualizations I might talk about them in another video. So I leave them as is for the time being, because the purpose of this video is just to how to run a simple and useful analysis. So far I have these parameters, and I'm going to click go. My data set is pretty small, so I assume it will not take too much time. Yes, it immediately gives me this message. It's not an error message, because CiteSpace says the CiteSpace will rerun the process with non-empty intervals. That's okay, so just click OK, because some of the intervals were empty. Then there we are, and this message appears. So the time frame is from 2016 basically to 2020. I think I had chosen 2015 if I'm not wrong. And then qualified records is 307. So that means the data that I inputted included 307 papers. But here, look at the bottom of this interface. You see the merged network nodes or publications. Actually, every node is one publication, is 262. So out of 307 publications, 262 papers were in the analysis, because the rest of them had no connection with these 262 papers. So they were left out of the analysis. For this number of nodes, we have 1938 links. Actually, you can calculate an average. You can divide, let's just do that really. Let's see on average how many links we have per node. So it's going to be 1938 divided by 262. Yes, and that's it. On average, we have around seven links per node, which is not too bad really. That's a well-connected network for a small sample like this. So now you can visualize it. I'm going to choose visualize to get the visualization. This is where the magic happens. And yeah, two windows pop up. One is this control panel, and one is the actual visualization panel, which interface, which, as you can see, is working now. I'm going to minimize this and just wait for this analysis to finish. If you don't like to wait for a long time, you can just click pause here, and that will be enough. But since my network is small, it's going to stop soon. If you have a large network, it's going to take a long time actually. So I've got these two arrows that are pointing sideways. I'm going to click the one on top, so that small part of the window will appear, and then the space will be freed for me to see. Now I can wait for more time here. This window is called control panel, as you can see. What you could do is really to close this window if you think that it's bothering you to see a small window, but you can always call it back from Windows, Control Panel, and click OK. Just click on it and you'll get it. Okay, so I'm gonna pause here because the network is now the visualization, and let's say the cosmetic part of the analysis is the first phase is over. I'm going to pause here, and I would like to invite you to continue watching by watching the fourth part of this video. Thank you very much for your attention. If you liked the video, please give it a like, and please come back for the next section.